So let's talk about tracking iterations. Let's talk about tracking code that contains loops. You can use this for simple loops, definitely for semi-complex to complex loops. This is a strategy I have coined offloading, right? And the key here is we want to offload the tracking of trivial data to paper and pencil. Now, here I did an extreme case. There were many different factors to this piece of code that was supposed to be able to identify prime numbers, right? So we need to track our way through A, which are index positions inside of an array. A is an array of integers uh, that increment by one. So that's a given. You can't see that, but A, the no actually A are the index position. It's an array. It's an integer array called numbers, and they're just numbers like one through 20 or what have you. So we're going to track A. And this is something you choose to do. Simple stuff. I'm going to track I, the inner loop. Starts at 2, right? But like numbers, it iterates by 1. Okay. And then I chose to track the limit. I want to know when the array, when the inner loop is functioning and when it's not functioning, based on has it reached its limit. And then I want to, over here on the left, just keep track of our little test here, which we will find is erroneous. Okay, so let's go through this. Um, the 5 factors I chose to track. Imagine students trying to track this type of stuff in their head. This happens year after year, by the way. So A was my index position for an array of numbers. All right, so this takes about 5 seconds for this column. I starts at 2 and iterates by 1. Okay, another 5 seconds of time to line this up with A. Then we want to know what is A divided by 2. We want to know this because this controls whether the inner loop is running or not. It's a helper. All right, and this is very, very easy math. I'd say this, all right, we can give this one maybe 20 seconds under pressure. And we want to know, is I less than A divided by 2? I'd say maybe another 20 seconds or so, just because. These are all false, by the way, which means our inner loop is going to run. Okay, so our inner loop is not a limiting factor. And then A mod I. And because of these two columns and the pattern that exists between them, A mod I is going to always equal 1, which means this will always be false, and this will never fill up with prime numbers. Okay, over here on the left, this A mod I will equal 0 will always be false, and our prime number, our solution set, will never fill up with prime numbers. And so we know that we have some erroneous code because um, we should be able to, let's back up, choose a different color. Let's go with green. We know that the number 2 and the number 3 and the number 5, right? When tested, they should have passed the test and they should have come out with a mod of 0. So we know we have some erroneous code. This is called offloading. Okay, never, never, never attempt to track multiple pieces of data in your head in a test situation like this. I mean, just getting this on paper. I can get this on paper in less than a minute, you know, and even if it takes 2 minutes to get it on paper, you have 2 minutes per question. You have a little better than 2 minutes per question. You can get this down on paper in 2 minutes, and you can make all kinds of decisions from having this in front of you. And usually the answer just pops out at you, you know, once you can see this, you know, demonstrated in this way. So always, always, always offload, let the brain, give the brain the job of doing some heavy lifting. Allow pencil and paper to keep track of menial tasks like which iteration you're on, menial variable changes, as much as you like. But don't try to track all of this in your brain. It's a rookie mistake, and it gets kids every year, who are untrained.